Welcome to the 10th episode of History Bites in 2022. My name is Anna Patterson and I'm a Visitor Experience Assistant here at Guelph Museums. History Bites is a 1-hour-long casual conversation during which we chat about the latest exhibitions, latest news, and other happenings at Guelph Museums. Today I'm going to be deviating slightly from my typical offering of fashion history, and we're going to be looking at some science history and how we can see that reflected in our collections. Before we begin doing that, I would like to take a moment to focus our thoughts within an awareness and an acknowledgement of the land. Guelph is located on the ancestral homelands of the Anishinaabe peoples, specifically the traditional territory of the Mississaugas of the Credit First Nation. The place we now call Guelph is on land that's described in the Between the Lakes Purchase No. 3 Treaty of 1792, an agreement between the Mississaugas of the Credit and the British Crown concerning over 3 million acres of land between Lakes Huron, Ontario, and Erie. Today, Guelph is home to many First Nations, Métis, and Inuit peoples. Guelph Museums commits to the Truth and Reconciliations Commission's calls to action and to doing more to learn, share, and support truth and healing. Today we're going to be discussing a topic that's related to our most recent exhibition here at Guelph Civic Museum, which is Iron-Willed Women in STEM. Women have made significant contributions to STEM and continue to do so, but their stories are often untold. Why is that? Do women and girls see themselves equitably represented in science, technology, engineering, and math, or STEM, fields? The traveling exhibition that we have here at the museum is from Ingenium Canada, and it recognizes the crucial role of women in STEM. Through text and images, the display tells the stories of historical and contemporary women in STEM, their scientific contributions, as well as their challenges in the face of persistent systemic barriers. Working with Dr. Joanne O'Meara from the Department of Physics at the University of Guelph and co-founder of Royal City Science, this exhibition will include stories, images, and artifacts of local women in STEM. This exhibition recognizes the historical barriers faced by all women in STEM and acknowledges that BIPOC, Black, Indigenous, and people of color, and LGBTQ2IA+ women have faced and continue to face even greater barriers. For this month's History Bites, I decided to take a step away from fashion for a moment and take a look at something else that we can find readily in our collection and honestly in most museum collections and probably some of your homes as well, and take a look at the science and the history behind that, which is uranium glass. Now, uranium glass is something that has reached a lot of popularity recently with its resurgence, especially on social platforms like TikTok. But it is something that has been really popular and fashionable since the 1830s and 1840s, although we tend to think a bit of it as being limited to the Depression era, which isn't the case. It was popular for over 100 years before that. But I wanted to take a look at this uranium glass and see what we might have in our collection that is uranium. Now, uranium glass has a very unique feature that makes it pretty easy to identify, which is that it glows under black light. And so what I did in preparation for this video was purchased one of these little flashlights, which is a blacklight flashlight. And this was pretty inexpensive. They're very readily available. You can purchase them on Amazon. And I went through our collection to see what glows. And we have a few different items in our collection that do in fact glow. But diving in deeper to that, there were some things that glowed for different reasons, which was very interesting to me. So today we are going to take a look at uranium glass, the history of uranium, one of the very famous women scientists who is featured in our exhibition, Marie Curie, and then also take a little bit of a deep dive into the science behind black light or UV light and see what else it might be able to shine a light on in our collection. So you can't really talk about uranium glass without taking a look at the history of uranium. And it is absolutely fascinating and has an incredible connection to our exhibition, Iron-Willed Women in STEM. Let's go all the way back to the history of Marie Curie. Marie Curie was born November 7th in 1867 in Warsaw, Poland. She was the first woman to win a Nobel Prize, first person and only woman to win it twice, and the only person to win it in 2 different scientific fields. Her husband Pierre Curie was a co-winner on her first Nobel Prize, and that made them the first ever married couple to win, launching the Curie family legacy of 5 Nobel Prizes. Now, Marie Curie studied at Warsaw's clandestine flying university, and doing my research into Marie Curie, I had a big question. What's a flying university? How do I go? Do I get a broomstick? And the answer is, unfortunately, no. But it is because it is not so much a place that you go, but a concept. It can sometimes also be translated to the floating university, and it was basically an underground educational enterprise. During her early life, it was really difficult for Polish people to receive a higher education in Poland. And especially higher education opportunities for women were severely limited. So the university would often change locations to prevent Russian authorities from learning the location and then arresting the teachers and students. It was part of a national effort to resist the occupation that was occurring. And so it was really an amazing concept of a sort of underground university, which is how it got its name, Flying University. Marie Curie ended up earning 2 degrees in France and married her husband Pierre Curie in 1895. The other big event of 1895 was the discovery of the existence of X-rays. The following year, in 1896, it was discovered that uranium salts emitted rays that resembled X-rays, and they didn't depend on an external source of energy. It arose from the uranium itself. And so Curie decided to look into uranium rays as a possible field of research for a thesis. She used her husband and brother-in-law's electrometer to discover that uranium rays cause the air around a sample to conduct electricity. Her first result was finding that the activity of the uranium compounds depended only on the quantity of uranium present. She hypothesized that the radiation came from the atom itself, which was an important step in disproving the assumption that atoms were indivisible. Her studies included 2 uranium minerals, pitchblende and torbernite. She discovered that the element thorium was also radioactive. In fact, her research was so rich and fascinating that Pierre dropped his own work on crystals to join her research. She knew that she had to publish her finds, and in 1898, the 2 of them published the paper on the element polonium and announced the existence of radium. In fact, it was the Curies who coined the word radioactivity. Over the next 4 years, from 1898 to 1902, they published 32 scientific papers, and even announced that when exposed to radium, tumor-forming cells were destroyed faster than healthy cells. She was awarded her doctorate from the University of Paris in 1903. As a couple, they were invited to speak to the Royal Institution in London about radioactivity. However, she was not allowed to speak because she was a woman, and only her husband was allowed to present their research. She was awarded her first Nobel Prize in Physics in recognition of the extraordinary services they have rendered by their joint researches on the radiation phenomena discovered by Henri Becquerel. Marie at first was excluded from the nomination, but Swedish mathematician Magnus Gösta Mittag Leffler alerted Pierre, who complained, and then her name was added to the nomination. Tragically, her husband was killed in a road accident in 1906. The physics department of the University of Paris, however, decided to retain the chair that had been created for Pierre and offered it to Marie, which meant she became the first woman to become a professor at the University of Paris. In 1910, she succeeded in isolating radium and defined international standards for radioactive emissions, which would eventually be named the Curie. During her own life, she was not elected to the French Academy of Sciences. And in fact, it wasn't until 1962 a doctoral student of Curie's, Marguerite Paris, would become the first woman elected to the membership. Despite this, in 1911, she was awarded her second Nobel Prize, this time in chemistry, in recognition of her services to the advancement of chemistry by the discovery of the elements radium and polonium, by the isolation of radium, and the study of the nature and compounds of this remarkable element. After receiving her second Nobel Prize, she was hospitalized with depression and a kidney ailment, and she would remain out of her lab for the next 14 months. When she returned to her work, she was appointed director of the Curie Laboratory in the Radium Institute of the University of Paris, founded in 1914. The institute's development was interrupted by the First World War, however. During the First World War, she recognized the need for portable X-ray abilities. And after a quick study of radiology, anatomy, and automotive mechanics, she developed mobile radiography units, which became known as Petite Curies. She became the director of the Red Cross Radiology Service and set up France's first military radiology center, which was operational by late 1914. It's estimated that over 1 million wounded soldiers were treated with her X-ray units. After the First World War, her fame and recognition grew, and led by Curie, the Institute produced 4 more Nobel Prize winners, including her daughter, Irene, and her son-in-law. She continued to travel and serve on various committees until the end of her life in 1934. She died at the age of 66 from aplastic anemia believed to have been contracted from long-term exposure to radiation, causing damage to her bone marrow. She was also exposed to X-rays from unshielded equipment while serving as a radiologist in field hospitals during the war. And in fact, when her body was exhumed in 1995, French officials concluded that she could not have been exposed to lethal levels of radium while she was alive, and speculated that the illness was more likely to have been due to the use of radiography during the First World War. Pierre and Marie were reinterred to the Paris Pantheon in honor of their achievements and sealed in lead lining because of the radioactivity. Her papers and even her cookbooks are too dangerous to handle without protection, and they're kept in lead-lined boxes. She is responsible for overturning many established ideas in physics, chemistry, and society, and she intentionally refrained from patenting the radium isolation process so that the scientific community could do research unhindered. So Marie Curie was a really remarkable scientist. She not only made massive discoveries that affected the way that, honestly, world history would turn out, but she did it facing so many systemic barriers that were in place at the time because she was Polish and because she was a woman. She really overturned society's ideas of what women would be able to accomplish. And as we can see, she really did set the precedence for future female scientists to have better access to those organizations and universities that were unavailable to her in her early career. So what does she have to do with the uranium glass in our collection? Well, radium is actually found in uranium. So uranium is a chemical element. It's a silvery gray metal, and it was first discovered in 1789 and credited to scientist Martin Heinrich Klaproth. He named it after the recently discovered planet Uranus. It was then used as a fuel in the nuclear power industry, including nuclear bombs, and today fueling nuclear power plants. Both before and after the discovery of radioactivity, uranium was used in small amounts for yellow glass and pottery glaze. In nature, radium is found in uranium. The history of the use of uranium is really interesting. It dates back to actually 79 AD, so its use in decorative arts is ancient. The reason that it became so popular later on is kind of because its availability. Because radium is found in uranium in nature, you had to mine uranium in order to get radium. And radium was used in things like painting, clocks, and aircraft dials. All of this uranium was then left over from the radium process, and it meant that it was readily accessible to use for ceramics and glass. So we have been talking all this time about uranium glass, but what is uranium glass? Well, uranium glass is pretty simple. It is glass that contains uranium. It usually contains uranium in the form of an oxide diuranate, which is added to the glass mix before melting, and it's used for coloration. As I mentioned, the earliest known use of adding uranium to a glass mixture to achieve a yellow color was actually 79 AD in a Roman villa in Italy. Since then, it was also used during the Middle Ages in Bohemia for glass, and then it became much more popular in the 1830s. Now, what the actual substance was, of course, wasn't known at that time. It was known that it was a substance that, when added to glass, would make it look yellowy or maybe a little greenish. It wasn't until 1789 that uranium was actually identified, and then it was added to decorative glass for its fluorescent effect. James Powell's Whitefriars Glass Company in London, England, was one of the first to market the glowing glass, which then spread across Europe and North America. And it was once used to make tableware, household items, but eventually fell out of widespread usage due to the Cold War, meaning that all the uranium was being used for that during the 1940s and 90s, or up until the 90s, and so there just really wasn't uranium to go around. It was highly managed. So the colors really range from more yellowy colors to green, and then even to bright green, and then you can also get different colors as well. Really, the identifying feature of uranium glass is the fact that it contains uranium, which means it will glow under black light. It also doesn't just glow. It's very bright. It is really a beautiful thing, and we're going to show that in just a moment. Now, does it glow because it's radioactive? No. It actually is barely minusculely radioactive. It is because it is a fluorescent material that it glows. Now, there's a couple different names for uranium glass as well, and they do actually mean different things. So uranium glass is used to refer to glass that contains uranium. There are glass items that will look like it, but unless they have that telltale uranium, they aren't uranium glass. Some people also will refer to this as, very early on, one of the nicknames was canary glass because it looked a little bit more yellow. And that's probably what someone who lived during this time period would call this. It was then nicknamed, some of it was nicknamed Vaseline glass. Now, Vaseline glass has a very specific color, and this one over here, this hobnail design vase, is Vaseline glass. It's very classic, and that's because it is more of that yellow toned green. And the nickname really came from the color of Vaseline brand petroleum jelly. People thought that it looked like that, and so they nicknamed it Vaseline glass. And it's one of those things that most Vaseline glass is uranium glass, but not all uranium glass is Vaseline glass, because it's really based on the color that it has its name. Depending on the color, it can have different nicknames. For instance, these bowls would be known as jadeite, which is not made out of the material jadeite, but it refers to the color, and it's very specifically an opaque pale green, which this is a perfect example of. But of course there were other colors, including custard glass, which was an opaque or semi-opaque pale yellow. And then there was also Burmese glass, which was an opaque glass that was shaded anywhere from pink to yellow. Now, some people will also refer to this as depression glass. And this is another one where some uranium glass is depression glass, but not all depression glass is uranium glass. Depression glass refers to really any glass made during the Depression era, the late 1920s to the 1930s, about the beginning of the Second World War. So any glass produced during that time period can be referred to as Depression era glass or Depression ware. And it doesn't necessarily mean it is uranium glass. There was a lot of glass produced during that time that had no uranium whatsoever. So although some of the depression glass might be uranium glass, not all of it is. So the nicknames are actually a bit more specific than people tend to think. One foolproof thing is to call it all uranium glass because these all contain uranium. Now, how do we check whether our glass contains uranium? Well, as I said, we need our handy dandy flashlight. And this is something, an activity that has become really popular, really in thrift stores all over the world, as people will bring these highly portable little blacklight flashlights to test and see whether or not the glass that they have is uranium glass. So we've done a lot of talking. Now, let's see the glass in our collection actually glow. What we're gonna do is turn off the lights and see them glow. So it is a really, really cool phenomenon to see the uranium glass actually glow, especially in real life. It is a really, really cool feature of these glass items. So the items in this that I have out at the moment are all from our collection here at the Guelph Civic Museum. And I will start over here with the candle holder. Now this candle holder is actually part of our McRae collection, meaning that it was owned or connected to the McRae family. And this is part of a set. There are two, and this dates from the 1890s. I really love this piece. It's very structural, so aesthetically it is beautiful, but also it kind of does remind us that the uranium glass is much older than we tend to think of. There really is this common misconception that it is only from the 1920s and 30s, but in fact, this is from much older. Even though they didn't really know why it was glowing, what the properties of uranium were that made it glow, they knew that that the uranium added a really lovely color to the glass, and actually, depending on the light, would sometimes give off a very faint glow in sort of daylight, because of course sunlight there is UV rays in sunlight. Now, the Victorians didn't have a blacklight flashlight to check this out and really see it glow like this, but it is really cool that this is sort of a byproduct of the fact that they used uranium to color it green, or in this case, more of a yellow. This would probably be more of a canary glass color. Now over here, this is the classic Vaseline glass. This vase is a hobnail design. That is these sort of recurring little points on the vase. That's where the term hobnail comes from. This was really popular in the Victorian era, and then the design continued into the early 1900s. This one is very classically Vaseline glass, as I said, because it does have that yellowish, almost oily sheen to it that would remind people of what Vaseline brand petroleum jelly would look like. And so that's where it has that sort of classic characteristic of being a hobnail Vaseline glass vase. Now, the bowls in the middle here are probably one of my favorite glowing discoveries that we made in the collection. And that's because, one, they look so modern, and two, it's a very practical item. This is a household good. This is not a decorative item like the matchstick or the vase. These were actually part of a set that went with a sunbeam stand mixer. These are from circa 1930, so these are absolutely very classic Depression era glass. That you can call that not because it glows as it's uranium glass, but because it was made during the 1930s. But it does have the very classic jadeite tone. It is opaque, pale green glass, and it glows. And this comes with a set. So there's the large one, we have the smaller one here with the little lip on it, and then there's also another piece that goes with it that is basically a funnel dish. It would sit sort of upside down on the top of the stand mixer, and then had a metal funnel that would then go down into the bowl. So you could be mixing and adding your ingredients in. And I just think it is so interesting to think about the fact that people would just be using these in their regular day-to-day cooking lives. These ones were for fashion. This was because this was very fashionable. It would demonstrate the fact that you are up with the trends. And this one, although also trendy, truly just a practical good. We all have mixing bowls in our cupboards today, and I think that that is very, very cool. So we're going to bring up the lights again, and we'll take a look at another few items in our collection that glow. All right, here is our next batch of items in our collection that are uranium glass. Let's see them glow. So these items are also, as you can see, just glowing away. Now, they are also very different items. So again, over here, this one is a very classic Vaseline glass. You can see at the top here where it's a little bit more opaque, a little bit less clear than at the bottom. It has that kind of oily sheen to it that is typical of Vaseline glass, and it is that more yellowish color. And so that is, again, what would be considered Vaseline glass. Here in the middle, this one is a fluted bowl. As you can see when we turn on the lights, rather, it is sort of a yellowish creamish in the center, and then outside it's more of a rose. And so this could actually either be from the glaze that's on it, or from the glass, because this is almost a ceramic glaze. I do tend to think that it's probably from the glass because I feel like we would see a little bit more glowing around the outside edges, but it really could be either. And then over here we have our pitcher and tumbler set. So these ones look very, very cool. So we have this beautiful pitcher here. And we don't know exactly when this one dates from. It is a little bit hard to say, but I will say this would certainly not be Vaseline glass. It is really kind of missing that texture that would give it that nickname. This absolutely is uranium glass, though, as we can see it glowing away. So we have 4 of these tumblers in our collection that match the pitcher here. It is hard to say if this is Victorian or maybe early Art Deco. I would lean towards Victorian, but really it's hard to say. So we wouldn't be able to classify this as Depression glass or not, just because we don't actually know the year that it was made. So it's hard to say, but we can pretty much without a doubt say that it is in fact uranium glass. All right, so we're gonna turn the lights back on, and then we're going to take a bit of an opportunity to discuss why uranium glass actually glows under UV light, and what else might glow under UV light in our collection. Now, the artifacts that I have in front of me, you will probably realize, are in fact not uranium glass, on account of, other than this buckle here, they're not made of glass. However, they all have unique features that for different reasons make them glow under UV light. So we're gonna check again, see if they glow, and then discuss why they're glowing. So one more time, we'll turn off the lights and watch them glow. So what is a black light and how does it actually work? Well, black lights emit mostly ultraviolet radiation and only a little bit of visible light that are in wavelengths closest to the UV spectrum, which are indigo and violet. That's actually why black lights look dark blue or purple. Black light is the only foolproof method for identifying true uranium glass because it causes it to glow the classic bright, rich green color. But it isn't the radioactivity of the uranium that's causing it to glow. It's actually the uranium's chemistry that gives off the incandescence. Uranium fluoresces or glows under UV light because the UV light excites the electrons above the ground state, which then give off photons as they return to the ground state. So this artifact here, although it doesn't look like sort of the typical decorative item that would be made out of uranium glass, it's a little more functional. It's the bottom of a kerosene lamp. It does still have that telltale glow, which tells us that it is a form of uranium glass. This one I would not typically describe as a Vaseline glass, again, because it sort of lacks that little bit of transparency, and it is a little bit less on the yellow side, a little more on the green side, but it definitely has the classic uranium glass glow. And it's gives a good opportunity to see the way that uranium glass versus other glass will look under a black light. So if you see up at the top here, this green portion is the portion that is the uranium glass. And down here, it's actually really been kind of covered up with this paint. And so although probably if we were to scratch it, which we will not do, we would be able to uncover the uranium glass. you can see the difference in how this will glow and this one won't. So this artifact here is a great example that uranium glass was not limited to decorative household objects, but also to accessories. So this would be a small hair clip, could be a little brooch or a pin as well. It has the pin fastening at the back, and you can just see how well it glows. We'll take a look at it as well with the lights on, but you can certainly see that it has almost like a yellow diamond, canary diamond quartz kind of a tone to it. So it may have been it's hard to say, it could have been to emulate uranium glass, and it was just a yellow glass that they wanted to add to their own personal style. Or it could be that it was made to mimic a stone. And actually some naturally forming minerals in the world will glow as well, especially rubies. Rubies are known to glow under UV lights as well. And we'll talk about the science behind that shortly. But I think that this is just a really beautiful decorative item. And wearing this pin, especially if you were to go blacklight bowling, would be quite the fashion statement. Uranium is not the only substance that will glow under blacklight. As you can see, the paint on this turn-of-the-century souvenir dish is glowing under the blacklight, but it probably doesn't have anything to do with uranium. Any phosphorescent substance will glow under UV light. Phosphors are substances that emit visible light in response to radiation. Phosphors hit by UV light become excited and naturally fluoresce like the roses on the dish. Our eyes can't see the UV light as it leaves the black light, but some of that light gets reflected back to your eyes and has less energy and therefore falls within the visible range. When molecules lose the absorbed energy from the UV radiation, that visible photon is released, making the substance appear to glow in the dark. Phosphors can occur naturally or be man-made. In fact, your teeth and your fingernails contain phosphors. And unfortunately, so does the material that this object is made out of. This is made out of ivory, which is also a phosphorescent material. This is a measuring tape from around 1870, and it's two ivory pegs that are joined by a string. It's actually a specific device used in lawn bowling games to measure the distance between the balls and the kitty. So this item here is a doll's pearl necklace. As you can see, this is actually a really different glowing color than the other ones. Again, if we remember something like the little brooch, which fluoresces very yellow, these faux pearls are blue. And so different objects will glow different colors under black light depending on what they are. For instance, if they're a flying squirrel, they will glow bright bubblegum pink. And that is a true fact. So the basket that is here, obviously again, not glowing as much as the uranium glass in the background, but it does have these faint elements of fluorescence. It's much, much harder to see and may not be coming across on camera quite as well. But especially the ribbon here does have some elements of fluorescing. And the basket in general does as well. And that has to do with the way that different materials were treated, depending on what the substance is. So again, this wicker basket is obviously not made of uranium glass, like the item in the background, but it has its own unique features that do have a little bit of a fluorescing property. This lamp cover from circa 1890 is another object that it is hard to tell that it's fluorescing, kind of like the basket. It's made out of silk chiffon and a fuchsia colored taffeta. So you can kind of see underneath where the fuchsia taffeta is fluorescing. So just like how sometimes surfaces of wood can appear to fluoresce under UV light because of the coating applied to it, textiles can also appear to fluoresce because of the way that they were treated. If they were treated with optical brighteners, then they will fluoresce. And optical brighteners were used in silks and wools from the 1840s, polyesters and rayons from the 1960s, and sometimes in laundry detergents from the 1830s as well. So it can sometimes be hard to tell why exactly an object is fluorescing. For example, it might be tempting to think that this bottle is made out of uranium glass. However, it's actually the substance inside that's fluorescing. It's a bottle of oil of cinnamon, so it's actually the oil inside that is causing the fluorescent reaction. And we will see a modern example of this very shortly. Man-made objects can also fluoresce under black light. Optical brighteners were introduced into plastics in the 1950s, so there are lots of plastics that will glow under black light. For instance, this object, although it is hard to see in the video, is a Marshall ultrasonic watch cleaning machine by C&E Marshall Co. And it is the perma-ion cups on top of the machine that are actually fluorescing. So uranium glass, although the name of it and the way that it glows under UV light can look a little bit concerning, it actually poses almost no danger whatsoever to anybody. In fact, studies have shown that at the highest possible estimate of exposure, which would be someone who is bringing the uranium glass from a manufacturer to a distribution center, they would still only receive at most from that uranium glass 1 to 2% of the average American's radiation. And so basically what that means is that there's more danger from your average cell phone usage or air travel than actually from uranium glass. So if you do happen to get yourself a black light and find a piece of uranium glass in your collection or at your local thrift store, you can pretty much rest assured that you could use it without danger. The only possible issue is that it apparently can react with acids. So maybe don't use it to store your orange juice or lemon juice, but otherwise it would actually probably be fine to drink or eat out of. I maybe wouldn't recommend it, if not only because it's probably a historic item that you want to keep and don't want to risk breaking it. Now let's say you already have a blacklight flashlight or you want to get one and do some experiments around your own home with the flashlight. Do you have to have uranium glass to do so? No. Do you have to have any of the other artifacts that we've looked at this video, from the ivory measuring tape device to the faux pearl doll necklace? Also no. You can actually find everyday items around your house that will fluoresce under black light. And fortunately, it is not because they are radioactive, but because they have other inherent properties that will react to UV light. UV light is in a range that we can't see. And so when something like the blacklight flashlight is made, it's made using a process that when the light hits an object and then reflects back into our eye, it's lost a certain amount of energy. And so it then starts to appear in the indigo or violet range of the visible light spectrum. So that's why a black light kind of got its name. It has that purple or dark blue sort of color to it, is because the UV light has lost really just enough energy that we're then able to see it. So rest assured, just because something glows under UV light doesn't mean that it's radioactive. So we're going to do a little bit of an experiment today called Will It Glow? And this is something that you can try at home. So what I have gathered here are things that I was able to just find around the museum. And we're going to see whether or not they glow. So over here I have some green food color preparation. I have some ketchup packets, cotton balls, baking powder. I have vegetable oil, some cinnamon, and some pipe cleaners. And what we're going to do is we're going to turn off the lights, turn on the black light, and see which of these items glow. We're going to start with the green food coloring first. Okay, we're back in the dark again, and we're going to start over here with the food coloring. Now, it is very dark. I don't know if you can see me holding it up, but as we can see, there is no glowing happening. So we have come to the conclusion that green food coloring, at least of this brand, does not fluoresce under black light. And it's obviously also not stored in uranium glass. So the next item that we're going to test is the ketchup packet. Now bear with me as I open the package. It's going to get a little bit dark here. And I'm going to very carefully pour some ketchup out onto the Kleenex. Now a fun fact about me is that I actually don't like ketchup. So I don't want to get it on my hands. But I will do this for the sake of science. I will just make sure I don't have anything on me. We're good. Okay, now let us see here. Does the ketchup fluoresce under black light? It has like a very, very kind of pale orange kind of a tone. I don't know that I would say it fluoresces. Now, the internet did tell me that it would, so either not everything you read on the internet is true, or maybe I need to try this with a different brand of ketchup. So, who knows? Could be one or the other. That is an experiment you can try at home. Now, let's see here, what about cotton balls? In my hand here, I have a pile of cotton balls. And there's a little bit of some glowing action here, although I think the real trick is that they've sort of gathered some fibers from some other items that do seem to be glowing a little bit. So they are doing a little bit of fluorescing. Again, that could be maybe based on the treatment. For instance, something like modern paper, which fortunately I have behind me right here, will glow very brightly under black light, and that is because of the bleaching process. So it could very much depend on the type of cotton balls you get. The next object we have is baking powder, and we will see if baking powder will fluoresce. And I will hold it here. It looks a little bit bright, but I don't know that I would necessarily say that it is sort of fluorescing brightly under black light. So that is, I guess the answer to that is it doesn't really glow. Next up, we have our vegetable oil, and we will see if that glows. And we finally have a very distinct success. The vegetable oil is 100% glowing. It is giving off a very bright color. It's a very similar color actually to the uranium glass. And I can tell you right now that it is a plastic container, so it is definitely not uranium glass. And if we think back, we know that the oil of cinnamon in our collection also glowed. And so it turns out actually quite a few different oil products will glow under black light. Next up, we have some cinnamon. And it is doing absolutely nothing at all. So cinnamon does not fluoresce under black light. However, again, the internet tells me that turmeric will. So if you have some of that in your cupboard at home, you can always try that out. Now, last but not least, of course, we're a museum. We do lots of fun programming, so we always have a good supply of pipe cleaners on hand. And it turns out that pipe cleaners will absolutely fluoresce under black light. It's hard to really get across, I think, on camera just how much they're fluorescing. Oh, that's pretty good there. It is very much, it reminds me of a black light like bowling party or roller skating party, something like that. It has very much those colors, especially the orange pipe cleaners are very bright there, so that's fun. So pipe cleaners, yes, will fluoresce under black light. And there's lots of other different types of substances that will also fluoresce under black light, including things like human fingernails. Mine are painted, so this is a terrible example, but also your teeth. was a brief introduction to the new favorite game, Will It Glow? And as we've seen, some of the objects on the table in front of me will glow, some of them won't. Again, if you do a quick Google search of things that will fluoresce under black light, you'll find results like honey will also fluoresce, certain types of rocks or minerals will fluoresce, and all kinds of different substances, including different kinds of glues and pastes. And in fact, that is one reason why UV light can actually be really helpful in museums, because it can be used to identify things like repairs on ceramics, depending on the type of paste that was used. It can be used to check for the age of things. It can be used to date things depending on the age. If you have a paper item, older ones don't tend to fluoresce. More modern paper is usually treated with bleaches, and so they do tend to fluoresce. Different types of fabrics will or won't, depending on how old they are. Some older items will actually fluoresce depending on the laundry detergent or the types of silks or dyes that were used, and then there's kind of a gap, and then some items that were made in the 50s and 60s, like polyesters and rayons, those will also fluoresce, and so that can be helpful in dating items as well. Of course, probably the most glamorous or exciting version of how a museum might use a black light would be to check for forgeries in their historic oil paintings, because more modern paints tend to have fluorescent properties, whereas older paints don't. Now, I don't think we have anything in our collection that would quite match the sort of ages that you would need to have it be obvious whether or not something is a forgery. I wish we had, a Van Gogh Starry Night that we could check, but we don't. But those are the types of things that UV light can actually be really, really helpful for museums. And it can be part of a fun game at home. So again, these flashlights are pretty inexpensive. They're really easy to get a hold of. You can order them off Amazon, local toy stores will often have them as well. And then you can do that quick Google search and see what else might fluoresce. Or you can just turn off all the lights in your house and walk around with your blacklight flashlight and see what catches your eye. It can be really fun, and then you can also learn about the different chemical properties of the item and why it is actually fluorescing. So thanks everybody for tuning in for this month's edition of History Bites, where we talked about Marie Curie, uranium glass, UV lights, black lights, and pipe cleaners. So I do think that this was a really fun History Bites. I hope everybody enjoyed it at home. I hope you learned a little bit about the science and chemistry behind some everyday objects, and I hope that most of all you had fun and it inspires you to come down and check out our newest exhibit, Iron-Willed Women in STEM. Now, this whole time we have been talking about the fascinating uses of uranium and of UV or black lights and how we can use them in museums. Now, doing this whole experiment and figuring out in what objects in our museum are made of uranium glass or fluoresce for different reasons, we did also make a slightly creepy discovery. Some very innocuous objects will fluoresce under black light, and so in honor of the scariest month of the year, October, I would like to share some items that in and of themselves are completely everyday, normal objects that we have in our collection, but under black light, they do look a little unnerving. Thanks for joining, and happy Halloween!